Hi students, all of you welcome. Welcome to Suneel Engineering Academy. I am Suneel Kumar Bandaru. Students, in this Transformers through topic wise MCQ series, we have completed six sessions. I think it is the seventh one. If you want previous, click on the playlist. You can find out the previous. Okay. Let me check up to which we have completed in the previous. All these questions we have completed now. Students have given Telegram link in the description box. Click on that link and join the Telegram. And if you have not subscribed this channel, please click on subscribe button. So most of the question belongs to losses also completed. And now regulation based questions. Okay. So the regulation of a transformer in which ohmic loss is 1% of the output and reactance drop is 5% of the voltage when operating at 0.8 power factor lagging. So what is the regulation formula? Regulation percentage or cos phi or R per unit cos phi plus or minus percentage x sin phi. Okay. So we know very well the regulation curve. Coming to the regulation curve, so we are getting the regulation at this like this. So it is belongs to lagging. This belongs to leading. Okay. So regulation is 0 in case of leading only. So in lagging, always positive. Always positive. But in case of leading, there is a chance of 0 regulation, and this is the positive, this is the negative. So positive, 0, negative, all are possible. Okay. So here, if you want to get the regulation as minimum or 0, this is possible in case of leading only. So when we will get this value as 0, whenever there is a sign is minus, then only there is a chance of minimum or 0. Okay, so that's why we can say for leading, the regulation is percentage or cos pi or cos pi minus percentage x sin pi. Okay, so all of you got the idea? Minus, whenever you put minus, then only, for example, it is a 4 minus 4, 0. 0 is possible in case of leading. That means leading we have to take minus. For lagging we have to take the plus. In lagging always positive regulation, na? So our maximum regulation you can get. So if you want to get maximum, so then only the symbol is in the plus or minus, plus percentage x side. Okay, this is the simple way to remember the formula minus and plus. Okay, so here they have given percentage R. Ohmic losses are also considered as percentage R, that is 1% into cos pi. Power factor they have given 0.8, plus or minus they have given lagging. So for lagging it is the plus. So plus percentage x, reactance drop is considered as percentage x, that is 5%, into, if the cos pi is 0.8, sin pi is nothing but 0.6. Both are vice versa. If the sin pi is 0.8, cos pi is 0.6, like that. Okay, so 0.8 plus 3, 3.8. So the answer is option A. Okay, all of you clear? So it is a simple way to remember. For lagging, always you are getting positive regulation. Positive means you have to make it as positive in the formula. Leading, there is a chance of minimum or negative. So you will get minimum or negative whenever you put minus sign only. Okay, so that is the simple way to remember. Okay, if you like my remembering tricks, click on the like button. Okay, so the regulation of 20 kVA transformer in which percentage R is 3%, percentage X is 6%, the operating 0.8 power factor lagging. Lagging means again positive we have to take. Percentage R cos pi plus percentage X sin pi. Okay, percentage X sin pi. So percentage R 3% into cos pi is 0.8, percentage X 6%, sin pi if it is 0.8 it is 0.6, 2.4, 3.6, that is nothing but 6%. So answer is option A. Okay. Whenever they are giving lagging, we can simply eliminate this negative term. Okay. Coming to the next question. In some examination, they will give the option as minus 6%. Okay. So here lagging means plus only will get. So click on plus only. Coming to the next question. The regulation of a 20 kVA transformer in which percentage R is 2, percentage X is 6, when operating at 0.8 power factor. Same model questions, just they have given here leading. Leading means there is a chance of positive, negative or 0. Okay. So percentage R cos pi. So leading means to take minus now. Percentage X sin pi. Percentage R 2 into cos pi is 0.8. Percentage X 6 into is 0.8, here 0.6. 1.6 minus 3.6, that means minus 2. So answer is option A. Minus 2 means answer is option. Coming to the next question, guys. Maximum voltage regulation they are asking. Okay. Maximum voltage regulation. So from coming to the regulation curve, I have already given. Okay, this is in case of lagging. This is in case of leading. So this is the maximum regulation. In case of maximum regulation, regulation is equal to percentage R cos pi plus percentage X sin pi. Okay. So lagging only it will be happen. That means both resistive and inductive are there. That means Z, both Z is there. That is percentage Z. So maximum regulation is maximum regulation. If both are involved, so percentage Z is the maximum regulation. And regulation at unity power factor. This is the unity power factor. This is like 0.8, 0.6 like that, 0.8, 0.6 like that. Okay. So regulation at unity power factor. If the power factor is unity power factor, what about the sin pi is 0? So sin pi is 0 means reactive component is 0. Then regulation is percentage R into 1, percentage R only, or R per unit only. So regulation at unity power factor is nothing but percentage R. So these two are very important, guys. Here they have given maximum voltage regulation, that is percentage Z, that is 4%. So the answer is option A. Okay. 20 kVA transformer in which percentage R is 3%, percentage X is 5, percentage Z is 4, then regulation at unity power factor. Just now I have given regulation at unity power factor is percentage R only, that is 3% only. So the answer is option A. Full load voltage regulation of a power transformer is 0 when the power factor of the load is near at dash. When it will be 0? When it will be 0? I have already given this curve 2 times. It's difficult to draw the diagram in neat manner by using the pen tab, guys. So please adjust. Okay. So 0 at this case. Here unity power factor. So that means approximately is 0.8 and it is possible in case of leading only. So very near to the unity and leading. Very near to the unity and also leading. So in this case only there is a chance of 0 regulation. Okay. Unity and leading. Coming to the next question. The percentage regulation of the ideal transformer. The ideal transformer case, the regulation has to be 0 regulation. So we can give the answer as option. A transformer is supplied at 600 volt. Terminal voltage on secondary side is 230 volt at full load. And 0.8 power factor lacking. If percentage R is 1%, percentage X is 5%, then what about the turns ratio? So due to this resistance and reactance drops, we are getting the terminal voltage is in the drop. Voltage drop takes place. Okay. So if you are not considering about this voltage drop, then what about the turns ratio? N1 by N2 is nothing but V1 by V2. So approximate, you go with approximate, that is 600 by 230. So once 2.6 something na 230 2.3 something, correct? 231 232 means 460, that is 140 is there, 1400, 2.6 something you will get. So approximately 2.6 or maybe less. Why? Because if you consider the drop, this value is less now. So approximately 2.5. No need to do this one in detail. Why? Because options are very far, no need of that one. So if you want to find out exactly, you have to consider the voltage drop. What is the voltage drop? Voltage regulation. You will get percentage R cos phi R. Okay, 1 into 0.8 plus 5 into 0.6. That means 0.8 plus 3, 3.8% voltage drop is there. Okay, so 3.8% of the voltage drop is there. That means then you will get numerator, that is 600 in the 600 3.4%. Let us take 4%, 24 volts is less. So 576 or 577 like that. So then it will becomes less than, little bit less than 2.6. So 2.5 we will get approximately 2.5. Like that you can calculate. Okay. So if the options are very near, 2.5 is to 4, 1, 2.4 is to 1, 2.45 is to 1, like that, then only you need to calculate the voltage regulation and drop. Drop is approximately, if you consider it is a 4%, 4, 6 means 24. Okay, so like that you can calculate. Coming to the next question. Single phase transformer, the magnitude of leakage reactance is twice that of the resistance of both primary and secondary. With secondary short circuited, the input power factor is dash. What is the input power factor? Input power factor. Okay, so they have given R2, sorry, X2 is equal to 2R2. Then what about the Z2, guys? Root of R2 square plus X2 square na. R2 square plus X2 means 2R2. So that is nothing but 5R square root 5R. Okay, so if you want power factor, R2 by Z2. So R2 by root 5 into R2. So you can get 1 by root 5. So 1 by root 5 is the answer. So the answer is option B. So the answer is option B. Okay. So like that you can easily get the answers. In the next session, we will discuss the testing of the transformer, open circuit test, short circuit test, and all those. Okay. Students, if you have not subscribed this channel, please click on subscribe button, and also please encourage me with your likes and comments. Okay. So with your encouragement only, I can take more sessions, guys. Thank you so much.